Hi, this is Mr. Ward, and I'm doing a key here for Do Now 13.3. Okay, so we got our first question. What's the probability of drawing a king, then a queen, and then a 5 of any suit for all of those from a deck of 52 cards? Well, our first probability, so this is the probability of king, queen, and then 5, any suit. Okay, and the order is going to matter. So here's what we're going to do. We're going to have probability of a king is 4 out of 52. And then the probability, and we're going to multiply that times the probability of a queen, which is 4 out of 51. Okay, and then the probability of a 5 is 4 out of 50. So we multiply those times each other. And I need to state that this is not only does the order matter, but we're not replacing. If I don't say we're replacing, you can assume I'm not replacing, but I will fix that in the do now in just a second to make it really clear. So we're going to multiply that out. Now, 4/52 I can simplify into 1. I'll make that 1 out of 13, and I'll multiply that times now 4 out of 51 still. Can't simplify that, but I can simplify 4 out of 50 into 2 out of 25. Okay, so we can calculate all that. So I'm just going to plop that into a calculator. Boom. Okay, and I get this crazy number, but I'm not really that excited about that crazy number. I actually want to work out what 13 times 51 times 25 is. So let's do that. I want to get the denominator times 13 times 51 times 25. Okay, I get 16,575. So my denominator is going to be 16,575. And my numerator is 1 times 4 times 2, so that's 6. And that is the probability as a fraction. However, I know you would like to see it as a decimal, so let's go back to that version. So I've got this. So I get 0.0048 to blah, blah, blah. So I'm going to round at this point. Okay, and that's the decimal version. So that's the decimal version rounded. And that is going to equal, I'll move the decimal 2 places, 0.048% rounded. So not a very good chance of getting that particular situation. Now, how would the probability change if the order of those 3 cards did not matter? Well, if the order of those cards didn't matter, then it could be king, queen, 5, king, 5, queen, 5, king, queen, 5, queen, king, queen, 5, king. It's there. So there are, in fact, 3 factorial ways that could happen. So what that's going to do is it's going to multiply the number of chances by 3 factorial. And 3 factorial equals 3 times 2 times 1, which equals 6. So it would multiply the chances 6 times. So we go back into here, and we take this number, and we would multiply it times 6. So I'm going to put parentheses around all of this, and we'll multiply that times 6. And we will get a new number, 0.002895. So if we round it to here, we get 0.0029. Okay, rounded. So let's put that in there. So 6 times our original probability rounds to about 0.0, what was that? How many zeros? 0029. 0.0029 or 0.29% rounded. Okay, that's a lot larger number. Okay, let me going to confirm that really quickly. I'm going to say so this is the percent, 0.048 times, that's not times 6. Yeah, I get about 0.29%. Okay, so we're going to get about a 0.29%, still really low chance, but better. Okay, what's the probability of drawing a diamond and then any card that is not a diamond from a standard deck of cards? So there is a 1 in, so it's the probability of diamond and then not diamond. Okay, and so that's going to equal 13 out of 52 chances to get a diamond. And then we're going to have, if we drew a diamond, now we have how many cards left? We have 39 cards we have 51 cards. So out of 51 cards, there are now 39 cards that are not diamonds. And so that's going to work out as your probability. So 13 over 52 times 39 over 51. I'm going to simplify those fractions to make my life a little easier. 13/52 is 1/4. And 39 over 51, I can factor 3 out of that, and I end up with 13 over 17. And I don't need a calculator to work that out because 1 times 13 is 13, and 4 times 17 is 68. So that is my probability. But if you would like to see it as a decimal or percent, we can do that. Okay, so we've got 13 out of 68, which is about 0.19. So equals about 0.19 rounded, or 19% rounded. So that's not a bad chance of getting a diamond and then not a diamond. And love to hear your ideas about a probability carnival. And I'm going to stop the video now, and I hope that helps.